Hello everyone, this is Ashok, your personal guide and mentor. I welcome everyone to my YouTube channel AKB Tutorials. Here we are going to discuss and cover some important concepts of mechanical engineering that are very useful and helpful for competitive exam and job interviews. So let us start today's session. Hello, welcome everybody to my channel AKB Tutorials. I am Ashok from AKB Tutorials. Today we are going to see one of the most important topic, that is stress strain analysis in a complex system. So before going to that, so we will discuss one small topic, that is stress strain diagram for a brittle material. That is stress strain diagram for a brittle material. Okay, so we have discussed what is brittle material. The body under load. So whenever there is a very small deformation produced in the body under load, the body is known as a brittle body. In case of a ductile body, there is a large deformation produced in the body before failure, but in case of brittle material, there is very small deformation produced in the body or no deformation produced in the body before the body fails. So that materials are known as brittle material. Like cast iron is a brittle material. So now if we do this stress strain analysis of this material, the curve whatever we will get is plotted here. Say this side denotes the strain and this side denotes your sigma stress value. Then the curve will be straight line up to some point. After that the curve will bend and fail here. So this is your proportional limit, that is P, and corresponding stress is the proportional limit stress is given by sigma P. Sigma P is the proportional limit stress and P is called proportionate limit point. And up to this the curve is a straight line. After that, if the load is increased, the curve will slightly bend and the body will fail. This is the failure point. So no much information is obtained from this test. Even what is the yield point is not obtained by this curve. So to find the yield point, we are considering we are drawing a parallel line here, so which will intersect here, and this stress value we are considering as sigma y value. So this is actually called proof stress. What is proof stress? It is the stress at 2% deformation, 0.2%, sorry, 0.2% deformation. So 0.2% deformation, the stress which is produced at 0.2% deformation is called the proof stress, and this is considered as the yield strength of the body, because the upper yield point or the breaking point is not fully obtained by this test. So that's why the yield stress is denoted by proof stress. What is proof stress? It is the stress value at 0.2% deformation. So by drawing a straight line parallel to this line at 2% offset, so we get sigma y value. That is called proof stress actually. So now we will see the stress analysis in a composite system. So before going to this, what is a composite system? So till today, whatever cases we have seen, the cases are a single bar or single component taking the loads. But now, if the number of components more than one taking the load, then that is coming under a complex system. Suppose the heavy load, say heavy load is given by W is the heavy load. This heavy load is supported by say 3 equal bars. Okay. So these 3 bars are taking the load. Total load is W. W is a heavy load taken by bar 1, bar 2 and bar 3. So 3 bars may be made of same material, may be made of different material, and also the cross section areas may be same or may be different. So if the total load is shared by more than one member, then the analysis is coming under stress strain analysis in a complex system. So now W load is shared by 3 members, that is 1, 2 and 3. Say P1 is the stress developed in first member, P1 is load taken by first member, P2 is the load taken by second member, and P3 is the load taken by third member. So from equilibrium we can write, so for equilibrium of the system we can write total load is equal to P1 plus P2 plus P3. That is load taken by first member plus second member plus third member is equal to the total load. That is the first equation of equilibrium. And the second equation will come, that is, if the deformation takes place because load W, the deformation will be equal on all the bars. Say delta L is the compression because of this compressive load applied over the members. Delta L is the deformation, and the original length of the members, say the length given as L. So strain produced in the first member, strain produced in second member, as well as strain produced in third member will also be equal. So that means we can write delta L by L, that is the strain produced in first member, delta L by L is the strain produced in second member, and delta L by L is the strain produced in third member. So epsilon 1 will be equal to epsilon 2, and that is also equal to epsilon 3. So now let us see the first case. Case 1, that is composite system of equal length, composite system of equal lengths subjected to load. So we have seen now. Okay, again we will see. Say the 3 bars. So bar 1, bar 2 and bar 3. These 3 bar supporting a load or a heavy load is suspended with the help of 3 bars. Bar 1, bar 2 and bar 3. All the bars have equal length, but the cross-sectional area or the material are different. So that means cross-sectional area of the bars may be same or different, and the material of the bar also may be same or different. For time being, we are considering this is made of copper, this is made of steel, this is made of aluminium, and the heavy load is suspended under the bar. So 3 bars are supporting this load, and say the load value is W. So W load is supported by 3 members. The length of 3 members is same, and the cross sectional area, say it is different, and the material of the bars also different. So under this condition, to maintain the equilibrium, let P1 is the load developed here, P2 is the load developed in second bar, and P3 is the load developed in the third bar. So the first equation of equilibrium we can write easily, that is W is equal to P1 plus P2 plus P3. And because of load W, say the deformation is taking place, some deformation is taking place, and this weight is lowered by some amount, say this is the final position of this load W. It comes down by, say, this much amount. It is given by delta. So delta is the deformation taking place on all the bars. Original length of the bar, as seen from the figure, it is equal on all the bars. So now original length of the bar is equal, and deformation produced in the bar is equal on all the bars. So thereby strain produced in all the bar will be same. So strain produced in first bar, epsilon 1. So that is given by delta L by L is equal to, also we can write, that is epsilon is equal to, so we know sigma is equal to E into epsilon. So we can write delta L by L, that is epsilon is equal to sigma by E, sigma by E. And what is sigma? That is P1 by A1 into E. P1 by A1 into E, epsilon 1. Similarly, we can write epsilon 2, that is also delta L by L, the stress developed in bar 2, say this is sigma 1. So sigma 2 by E2 is equal to, you can write sigma 2 is equal to P2 by A2 into E2. And the strain developed in bar 3, epsilon 3, you can write delta L by L, that is equal to sigma 3 by E3, and that is equal to P3 by A3 into E3. So We have considered 3 bars. 3 bars are taking the load. The length of all the bars are equal. P1 is the load taken by first bar, P2 is the load taken by second bar, and P3 is the load taken by third bar. Young's modulus of elasticity of bar 1 is E1, second bar is E2, and third bar is E3, and cross-sectional area say is different. So A1 is the cross-sectional area of first bar, A2 is the cross-sectional area of second bar, and A3 is the cross-sectional area of third bar. So the first equation what we have got, total load taken by 3 members, that is W is equal to P1 plus P2 plus P3. So we can write P1 is equal to sigma 1 into A1 plus P2 is equal to sigma 2 into A2 plus P3 is the sigma 3 into A3, where sigma 1, sigma 2 and sigma 3 are the stresses developed in bar 1, bar 2 and bar 3. And another way also we can calculate. So these equations are sufficient to solve the problem. Anyhow, in another way, so strain produced in the bar is delta L by L in all the bar, or in each bar strain produced is given by strain produced in each bar is equal to dl by or delta L by L. Okay, and in this case epsilon 1 is equal to epsilon 2 is equal to epsilon 3 because the initial length of the bars are same and also the deformation produced in all the bars are same. Thereby epsilon 1 is equal to epsilon 2 is equal to epsilon 3. So load taken by first bar, load taken by bar 1 or first bar is given by, that is sigma 1 into E1, sigma 1 into area A1. Or we can write sigma is equal to E into epsilon, sigma is equal to, so from Hooke's law we know sigma is equal to E into epsilon, so sigma 1 is equal to E into strain produced in first bar is equal to E1 into epsilon 1 into A1. So we have got epsilon 1 is equal to, or epsilon 1 is equal to dl by L, because epsilon 1, epsilon 2, epsilon 3 in all the bars are same. So load taken by first bar, that is given by P1 is equal to E1 into epsilon 1 into A1. Similarly, load taken by bar 2 is given by E2 into epsilon 2 into A2, and that is equal to P2, and also P3 is the load taken by bar 3 is given by E3 into epsilon 3 or dl by L into A3, so that is equal to P3. So once we know P1, P2, P3, so we can easily find what is the stress developed in bar 1, bar 2, bar 3. So stress developed in bar 1 developed in bar 1 is equal to, what is the load taken by bar 1 is P1. So we can write P1 divided by A1. So that is the sigma 1. Similarly, for bar 2, we can write the load taken by bar 2 is P2 divided by A2 is equal to sigma 2, and load taken by stress developed in bar 3 is given by P3 by A3, and which will give you sigma 3. So by this way we can calculate the stress and strain developed in a complex bar. So when the load is shared by number of members more than one, then that is coming under the composite system. Total load is shared by first, second and third member. So P1, P2 and P3 are the, say, considering P1, P2 and P3 are the load taken by member 1, member 2 and member 3. And strain developed in all the bars are same. Now we will see the another case. The composite system of unequal lengths subjected to load. Consider the figure. So this is the figure. Here, say this is the bar 1, the bar 2, and this is bar 3, and the heavy load is acted over these 3 bar, and it is seen that the second bar is not taking initially, is not taking the load. So total number of bars 1, 2, 3. 3 bars. 3 bars are taking the load, but initially the load is acting only on 2 bars. That is first bar and third bar, as per the figure. So this is the support. So how to solve this problem? The load, total load applied over this system is capital W. Now this first, initially the deformation will take place in bar 1 and bar 3. The bar 2 will not take any load, will not take any load because there is a gap. So let this gap is delta amount, there is a gap, say 5 mm, 10 mm or 1 millimeter, 1 centimeter, whatever may be, there is a gap. If due to this load the deformation of bar 1 and bar 3 takes place more than this delta amount, then the second bar also will take the load. Now we don't know, in this case, to solve this problem, let the deformation is taking place up to this. Total deformation is taking place, say, or the load is coming down by X amount. Okay. So considering load taken by member 1 is equal to P1. Similarly, load taken by member 2 is equal to P2, and load taken by member 3 is equal to, say, it is P3. So load taken by 3 members is given by, say, P1, P2 and P3. So we can write W is equal to P1 plus P2 plus P3. So that is the equation of equilibrium. So we can also write what is P1 is equal to stress developed in bar 1 into area of bar 1 plus stress developed in bar 2 into area of bar 2 plus stress developed in bar 3 into area of bar 3. So this is the equation, this equation we have got. Now what is the deformation produced in bar 1, bar 2 and bar 3? We will see the deformation produced in bar 1, bar 2 and bar 3. So the deformation produced in bar 1 and bar 3 is x, and say L is the length of bar 1 and bar 2 because it is shown in figure that these two lengths are equal. So the strain developed in bar 1, strain developed in bar 1, that will be equal to x by L. Strain developed in bar 1 is equal to x by L, and that also equal to the strain developed in bar 3. But bar 2, the deformation produced in bar 2, what is the deformation produced in bar 2? Deformation in bar 2 is given by x minus delta. So that is the deformation produced in bar 2. So thereby the strain produced in bar 2, strain produced in bar 2 is equal to the deformation, that is x minus delta divided by, as the lengths are not equal, say this length is say L1, so L1, so strain developed in bar 2 will get. So we have got the strain developed in bar 1, bar 3 as well as the bar 2. So now let E1 is the Young modulus of elasticity, E2 is the Young modulus of elasticity of bar 2, and E3 is the Young modulus of elasticity of bar 3. So then by using Hooke's law we can find what is sigma 1. Sigma 1 is equal to E into epsilon 1. What is epsilon 1? It is given by x by L. So we can write E into x by L. Similarly, sigma 3, the stress developed in bar 3 is equal to E into epsilon 3, or sorry, E1, E3. So we can write E3 into epsilon 3 is equal to x by L. And the stress developed in bar 3, bar 2 is equal to sigma 2 is equal to E2 into epsilon 2 is equal to E2 into epsilon 2 is given by x minus delta divided by L1. So if we substitute all the values, then we can find what is the stress developed in different bars, strain developed in different bars, as well as P1, P2, P3. That is load taken by bar 1 is given by sigma 1 epsilon 1 AA1, bar 2 sigma 2 A2, that is equal to P2, and P3 is given by sigma 3 into A3. So I hope with this derivation you can solve the problem easily. So these are the derivations related to composite system. So in next class or in some class we will see some problems related to the composite system. So this is all about the composite system. So friends, so if you like this video, please, if it is helpful to you, then like, share and subscribe the channel. Thank you. See you soon with this. So today I am completing this video. Thank you all. That's all for today's session. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.